Welcome to the Public Safety Innovators Podcast. Connecting you with trendsetters who are leading innovation in public safety and expert advice on growing your own post-law enforcement business. And now, your host, Adam Wills.
Hello and welcome to episode 37 of the Public Safety Innovators Podcast. Today on the show, we are going to talk about next generation technology for the purpose of crime scene analysis and investigation. Three-dimensional virtual reality crime scene reconstruction is poised to change the future of criminal investigations. You know, when having this conversation, I can't help but conjure up memories of watching Star Trek as a kid and seeing characters on the show using the holodeck to physically manipulate virtual objects in order to solve mysteries. It's amazing to me that now, just a couple decades later, the capability is very close at hand. My guest on the show today, Eugene Liscio, is a registered professional engineer in the province of Ontario, Canada, and is the owner of AI2 3D, a consulting company that specializes in 3D forensic documentation, analysis, and visualizations. Eugene has testified in court in both the US and Canada, utilizing 3D technologies such as photogrammetry and laser scanning, and has also provided interactive 3D crime scene reconstructions to aid juries. In this episode, Eugene is going to share with us how 3D crime reconstruction is being utilized, how your agency can begin to implement the technology, and what he believes is in store for the near future. Welcome to the Public Safety Innovators Podcast. Today we have Eugene Liscio on the podcast from AID 3D Forensics, and today we're going to talk about 3D forensic technology and how it applies to public safety investigations, law enforcement investigations, and reconstruction. So, Eugene, welcome to the Public Safety Innovators Podcast.
Hey, thanks a lot. It's a pleasure to be here.
Yeah, it's good to have you on. So today we're going to talk about 3D forensic technology. Let's just kind of dive right into that and pick up from there. I know it's kind of a broad door that I just left you, but can you kind of give us a rundown in general of what you guys do at AID 3D Forensics and the technology you guys employ?
Yeah, sure. AI2 3D. So that's
oh, I'm sorry. Sorry about that.
No problem. Whenever I talk about 3D forensics, I kind of have given it a very broad definition in that it's really the use of 3D technologies for the documentation, analysis, and visualization of evidence. And so, like, documentation is all the cool tech that people like to use, the laser scanners, the drones with, camera and making photogrammetry and all this sort of stuff. And then there's the analysis part where you take the data and then you got to do something with it. So, depending on what application it is, whether it's for shooting reconstruction or bloodstain pattern analysis or something like that, you do something with it. And then finally, it's the visualization. It's how you present it afterwards. And so, whether it's including something inside of a report, what are the different ways that you can take this 3D data and then present it to somebody? So that's it. Kind of it in a nutshell. But the two main areas that I've really been focused on in the past sort of 10 years or so, I always call it the two B's. It's not bed and breakfast, but it's blood and bullets. So bloodstain pattern analysis, looking at the bloodstain patterns and what we can do with them, what kinds of different types of analysis we can do with them, and then shooting reconstruction. There's just been a lot of especially the last few years, officer-involved shootings. This just seems like I'm getting a lot of calls on that. So reconstructing those types of events has been a pretty big deal.
So from your perspective, what would you say is the single greatest advantage of employing 3D forensic technology in a law enforcement capacity?
Well, there's probably a few, but if you think about, let's say there's a
Okay.
shooting or there's something going on, and all of a sudden, you get there and you've got to document something really quick. And this could be for a crash scene, it could be for a crime scene or whatever. But first off, the speed of documentation and the quantity of information that you get from 3D data. That right off the bat is huge. And so if you look at traditional techniques, like even hand or manual techniques that people would traditionally use, a tape measure and plumb bob or one of these rolling wheel kind of things or whatever, I mean, they're great for very simple environments. But as soon as you start talking about, okay, we found a body in a forest and the forest is not level, it's got like ditches and it's got elevation problems and there's trees and bushes everywhere. Now that becomes a problem. So using manual techniques becomes really, really problematic. Speed of documentation. So when you think about just take a very small apartment, the fact that you can bring something like a laser scanner inside and then capture everything in the span of minutes, really. There's no other instrument in the world like the laser scanner, for example. You just can't capture that much data in so little time. And so those are some just, the initial advantages when you're in the field. Now, when you're back at the office, there's certain things that you can do with 3D data that you can't do with any other means. So it kind of opens up the door to other types of analysis that you could never do before. So that's super helpful because things that people would never even try by hand or using manual techniques, they'll now try with 3D data or with point cloud data or mesh data, as we refer to it. So, and then finally, on the back end, people are talking about virtual reality now. They're talking about, 3D printing. They're talking about all these other things. So it just opens up a whole bunch of doors for you, and the quality of your work, the way, how it's presented, whether it's a trial or even to your colleagues, like the chief and the investigators, they look at it and they go, damn, that's cool. Like it looks cool and it's valuable because it contains some really important information.
Yeah, and certainly that visualization is a big benefit in the courtroom as well. Being able to really visually tell the story of things that happened or how it transpired to the jury and to your defense or to the judge. Obviously that visualization makes a huge impact versus just submitting a report and having an officer testify in the stand or share some still photos.
Yeah, we still get that all the time. So like we have a case right now where, we're modeling gunshot injuries on a body. And, we're presenting this to some people and as soon as they look at it, I mean, there's no denying what you're seeing. I mean, it's very clear to them what they're looking at and it's very intuitive. And, a lot of these shootings, they're not all straightforward. Some of them are quite complex. The area that you're in is complex. It's, elevation differences and things like that. And it's not always something you can easily get with just a camera by taking a picture, right? So, a camera is fantastic, video and having photographs. But, it's sort of a view from a certain perspective. And depending on the kind of lens you have or whatever, it can kind of give you a false sense of depth or a false sense of elevation or whatever. So, having it
Sure.
in 3D gives you a more true to form representation of whether it's a crime scene or a piece of evidence or whatever it might be.
Yeah, I think the cold case homicide investigators of the future in 20, 30 years from now are really going to be thanking us. But I guess by then, maybe technology will be so much different, they'll still be cursing us. I worked a cold case homicide several years ago that was from the mid 80s. And it was tough, man. I mean, digging through these boxes of stuff and you're going, man, what were they thinking? And why didn't they do this? And why didn't they do this? And then you really stop to think about it and you go, well, it was just different. Like this was the way that cops investigated these crimes at that time. And the technology has evolved to the point now where we expect something different and we expect something more than what they had at that time. And so I suspect maybe that same conundrum will exist in 20, 30 years when they look back at our 3D scans and still feel like it's insufficient, right?
Yeah, it's a good point. Yeah, I've worked on some really old cases as well, and same thing. How people documented crime scenes back then versus today. There's obviously been a shift in mentality and attitude and technology. Technology has played a
Yeah.
huge part. So yeah, it's a good point. And 30 years from now, they're like, oh man, can you imagine? They didn't have this instrument and this instrument. How did they work back then? How was it possible?
Yeah.
You know,
Why didn't they
so
collect DNA, right? I mean, that
that's
wasn't
right,
even a thing.
right, right.
Right.
But it's an interesting
Yeah.
point. Like, for example, I always say, what if we were collecting biological samples before we knew what DNA was? Then we could, it would have had a whole bunch of opportunities there. And so I
Yeah.
don't know if that's the same for 3D data, just collect it and then maybe there's something we can do with it in the future that we can't do now. I don't know. But
Yeah.
yeah, but it's an interesting point for sure. Um, yeah. And, like there's a lot of things today where people are like, for example, body cams are really popular, right? So body cams are coming
Hmm.
more and more useful, and it's great because it gives like an officer's perspective, and but it's not what the officer is seeing, right? So the officer could be looking another way, but the body cam is pointed in another direction or something like that. So I always say 3D
Right.
data
Yeah.
is sort of a geometrically and often with color as well, can give you a more true representation of something. Like if you just take something simple like a boot or a shoe, it's curved surfaces and all kinds of stuff. So being able to get all that curvature and an accurate accounting of the geometry and everything else can be super helpful in an investigation, whether you're doing whatever. It could be a bloodstain pattern analysis or shooting reconstruction, whatever it might be. Just having good data is important regardless of what it is.
Yeah, absolutely. What is your take on the availability of the technology now? Because when I started in my law enforcement career, this wasn't even like 3D forensic technology and scanning really wasn't at the forefront of anything. Like it existed, right? But it was still very new and it was really reserved for the large agencies with the big budgets, right? And the technology was different then too. I mean, they had to come out with this huge truckload of equipment to set up, and it took a long time to sit there and have the camera sit and rotate and the laser scanner and everything. And so I feel like up until even just as recent as a few or 5 years ago, we kind of were looking at this technology as this is only something that the big players, the big agencies with large budgets can really afford to have as part of their investigative tool belt. Do you think that's changed, or is it changing?
Oh, totally. Yeah, it's there's a lot of pressure on these big manufacturers now, excuse me, to come up with low cost tools. And just take an example of Intel. Intel makes these little sensors right now that you can buy for $200, and you plug them into your phone. Like literally, I can get my phone. I got a simple cable and the sensor, and it becomes a 3D scanner. Now, it's not going to
Wow.
be super high accuracy or whatever, but in many instances for outdoor crash scenes or whatever, if I just want to capture a car or something smaller, it'll definitely work. Take the example of the new iPhone 12, and the new iPad Pro. So they have a built-in LiDAR sensor. Now, the LiDAR sensor isn't, again, high accuracy, but there are companies that are taking that data and they're coupling it with other types of technologies to get you really, really good data. And so I did a video not too long ago where I showed the parking lot out here with a phone. So I took 5 minutes or so of just walking up and down and kind of using the phone, and I produced this 3D model. So we're not quite there yet because the data quality, the accuracy, and that sort of thing is not quite there. But I can tell you what, I'm really impressed with what a lot of people are doing with low cost sensors and even your digital camera. So every agency's got to have a digital camera, right? And anybody's got like one of these in their pocket, right? You got a phone, a mobile phone, or whatever. But most agencies, if they have a forensics department, they're going to have a nice, pretty good camera with a collection of lenses. And just having a camera means that you already have the technology to document something in 3D. So using photogrammetry. So photogrammetry is a technology that allows you to take multiple overlapping images, and then you can process them in software. So even if you don't have the knowledge of photogrammetry, but you knew how to take the photos, you can sort of freeze or you can document objects in 3D already with just your phone. So you don't even have to make the investment in the software if you don't want to. And there's even free software. There's free photogrammetry software if you wanted to pick it off online. So there are a lot of opportunities for people if they have a tight budget, or if you're at an agency where things are tough. You can still experiment with a lot of technology that is freely available, or that might even just be in your back pocket.
So let's talk a little bit more about the technology then. I mean, what sort of devices are you usually using to capture the scene in the first place? And then how are you taking that and putting it together in order to create this virtual environment?
Well, scale is important. Okay, so you have to keep that in mind. So depending on the object that you want to document, so there's a big difference between trying to get document a shoe, let's say, and then trying to get an area that's a mile or a quarter mile or something like that. So then there's what kind of accuracy level you want. So you have to kind of always think about those things. So the main technologies though are really, there's the laser scanner. So there's a number of different companies that supply these or make these terrestrial laser scanners, if you want to call it that. And those are the ones that look like they're about the size of a big digital camera, let's say, and they spin around on a tripod. Great for crash scenes, great for crime scenes. Then, of course, there's photogrammetry. So photogrammetry is where, just any digital camera, take photos and you can process that. And drones have become really popular. And it's not the drone itself. It's the camera that's on the drone. It's just a camera. So it's taking pictures and then you process those pictures. So a drone is great for very, very large areas, crashes or outdoor shooting scenes. You just capture, in 10 minutes of flight time, you can capture a ton of data, like a big wide area. And then there's the smaller stuff. So there's things called structured light scanners that are, great for, a body on the ground. There's stuff for, small pieces of evidence and even, very, very small details like your latent print, like fingerprints or fingers, actually, getting all the ridges and all the things on your fingers, getting down to very small things. But those are probably the main three. There are other technologies, like more in a lab type of environment. So, for example, micro CT, computed tomography. So that's something you might use if you're an anthropologist. And maybe you're looking at, the skull. You find a body, you want to get it scanned in 3D, but you get the internal components and the external components. There's even 3D microscopes. So if you're looking at recovered remains, and then all of a sudden there's a cut mark on bone. Right? Maybe you want to analyze the cut mark and you want to start looking at things. So we actually had an intern student that did a project not too long ago, and you're getting down to very, very, very small scales, but it's 3D. So there's a number of different
incredible
things. Yeah, some pretty cool options there. But the main ones: laser scanners, photogrammetry, and structured light scanners.
So if an agency wanted to get started with actually purchasing the equipment technology that they need in order to employ this sort of thing, where do they go to do that? What sort of cost are we looking at, and where do you go to get the training necessary for that sort of thing?
Yeah, like if you're looking at a laser scanner, there's a number. I won't say a large number, but there's a few major players out there that you could go to and you can pick up. And the cost-wise, you're looking at something on the order of about 70, anywhere between like 50, maybe even a little bit less. In some cases, depending on the model that you get, up to sky's the limit, right? Like 100, 120,000 or something like that.
Sure.
And so depending on what you're doing, you may want to look at one scanner over the other. So if somebody's doing just outdoor crash scenes or whatever, you may want to consider one scanner. Whereas if you're just doing like a lot more indoor crime scenes and stuff, you might pick another one. So that's kind of the cost thing. In terms of photogrammetry, if you're just, if you got a digital camera, you got that part nailed already. So that's not a big deal. And then the software will run you a few $1,000s. It's not that expensive. High-end photogrammetry packages.
Yeah.
Maybe 8,000, 8,000 or whatever. But they have, it's like they sell different packages or whatever. But you can for $200, you can get a package that will produce really nice 3D models, So that's not a major investment for most agencies. And then, if you start looking at smaller scanners that will do things like smaller pieces of evidence like shoes and things like that, skulls or whatever, those, they range anywhere, if you want a decent one, on the order of, 10,000 to about $25,000, right? But, buying the equipment is the easy part, right? The investment is actually in the training and in the time and,
Sure.
making sure that the people get the proper time, because a lot of these people working in law enforcement today, they're not just doing one thing, right? They're doing 20 things, and to just go, hey,
especially
here's a
smaller
laser.
agencies.
Yeah, exactly. Like, here's a laser scanner, go for it, go nuts. It's like, well, where am I going to fit this in, right? So that's the other sort of investment a lot of people forget. It's not the upfront money. That's the easy part. Once you get the money, it's everything else afterwards, right? Maintaining the skills and getting the right training. So, but yeah, those are some areas. And there's some like, for example, there's an organization called the IAFSM. So it's International Association of Forensic and Security Metrology. It's a really long name, IAFSM. But it was started by people at the FBI, Secret Service, different police agencies when these technologies were new. So back in about 2005 or so. And I was the president for about 4 years, and it was really great because you're bringing people from all over the world together that are exploring these technologies and trying to get in on there. So that's a good avenue if anyone wants to sort of get introduced and sort of wants to network with people who are doing the same thing. That would be a great thing. And there's even forums online where people can get involved. There's one called the Laser Scanning Forum. And if you went on there, there's a whole bunch of people. There's other people from law enforcement and such that are on there, and you can message back and forth and get some other assistance.
Okay. Now, you offer some training as well, don't you?
Yes, I do. So I offer training in a number of things. So I teach at the University of Toronto. They have a forensic sciences program. And so back in 2013, there's no one-stop shop to go and all of a sudden you have everything. So I decided that I would bring together a number of different aspects of my work and then put it together for students. So it's sort of a condensed version of a number of different courses that I offer. So one is I do train for a company called Faro. So there's Faro Technologies. Their headquarters are in Lake Mary. So they sell a scanner, and I am a trainer for them. So I've trained a lot of law enforcement agencies on how to do that sort of thing. But I also do photogrammetry training. I do training on how to use different types of software, and how to manipulate the data, right? So how to work with the data and feel comfortable with the data. So there's a few different. I've even done courses on bloodstain pattern analysis, on shooting documentation. Not all 100% 3D. But they will have some component of this 3D documentation, so that at least you know that it is an option for you. Yeah. Okay.
Well, I want to shift gears here just a little bit. We all love stories, and I'm sure that you have some stories or some use cases specifically where you have used this technology. What can you share with us?
Yeah. There's a number of different things, so let me just see here. What comes to mind? For example, suspect height analysis, right? So you get a suspect or whatever, and you're trying to figure out how tall they are. So there was a case, was kind of a local case here where they're looking for somebody with a specific height. And so one of the things you can do is if you take the laser scanner and you have CCTV video, you can couple the two together. So that's one nice thing. 3D technology will often play nice with images and such. And so it was a case where I didn't know how tall this guy was, but we did the analysis. We went through, and police come through, and they never told me. They never told me about the suspect's height or whatever. But I could see this guy was really tall. Like in the video, it's like he looks tall, like whatever. But he's kind of in an open area, so it's a little hard to tell. Anyway, we do the analysis. We send the report. Once I send the report, I'm like, oh, can you tell me how tall he is? They're like, no, I'm not going to tell you. I'm like, okay, so, we get to trial. I testify at trial about how tall this guy is. And, they still wouldn't tell me. So I waited until everything was done, and then they came back, and the investigator called me and said, hey, just to let you know, you got to put this one on your CV. Like the number that we got for this thing was, we were like within like a quarter inch of his actual height or something like that, right? For this guy. And because the guy is like five.
Wow.
I thought he was 6'5". He was 6'5" something. He's a tall guy, right? Pretty tall guy. So we got really close to that, and it just helped reinforce, that they got the right guy, like that who's in the video kind of thing. On shooting cases and
that's
shooting
really neat.
Shooting reconstruction cases, there's kind of a common theme here. And when you look at a car, for example, and or even a body, like it's happened a few times where somebody describes, for example, there's an officer and he says, I've got this guy and he's pulling something out of his jacket or whatever, right? So the officer gives a statement about what happened. And in this particular case, there's a subject up on the top of a set of stairs, and the officer says, "Hey, get your hands out of your pockets or whatever." Like he's F you, forget it, I'm not doing it. So there's a little bit of a problem. And finally the guy sort of makes a quick movement or quick motion. 3 shots fired. And basically it can help support, for example, what the officer said. And in the body, and when you look at the trajectories in the body, you can see how the succession of shots, how they were fired. And even that there's a rotation in this guy's body, because the shots go, and you can just see it perfectly, like as he's coming down. And the officer, what he said was, just was very, very consistent with, what was said there. So sometimes little things like that, help to support the case. There's been other things. I've been involved on some other things that I can't talk about. Things overseas in Iraq, and even I don't know if you know this, but in 2013, there was a shooting in our Canadian Parliament. So there was a guy, just a wacko, and he ends up killing somebody, and then he runs into our Parliament, and there's a shootout. There's a huge shootout inside of our Parliament, and can you imagine somebody going into the U.S. Capitol and there's a shootout inside the Capitol? Like it would be, it'd be crazy. But we're Canada, so it's not. It wasn't. Maybe didn't make a lot of noise or whatever. But it was a really interesting case to have worked on as well. But like all things, when you can see and when you can help the jury and the investigators really sort of understand what's happening, then it's that added little piece. I mean, it's never like, I did the job and case solved, right? It's not like that. That's not the kind of thing that really happens, but it gives clarity, and it helps people explain complex concepts, right? And that's I think the real benefit of what I'm doing and how it helps.
Awesome. So what do you see as the future then of 3D forensic technology? Excuse me, I can't talk apparently. What will we be capable of doing in the future that we aren't able to do now?
Yeah, it's an interesting point. I mean, so kind of what we talked about, where you're getting this mobile and low cost tools. So, being able to pull something out of your back pocket and then all of a sudden walk around a crime scene, all of a sudden you're capturing everything, right? That's kind of, that's an interesting concept, and it just makes the technology available to everybody. The other thing is, a lot of people have been talking about virtual reality, for example, and virtual reality is really great right now for a training, like for training, and to kind of help people kind of immerse them in an environment and then practice their skills. And so that's good. But there hasn't been a lot of work on taking virtual reality of an actual crime scene and then taking investigators back inside, and then, for example, overlaying the results of an analysis. So, for example, there's one that I did where there was a couple of bloodstain impacts in this room, and what I did was I did an analysis in the room, but I sent all the data to a colleague of mine in Germany, in Stuttgart, and so he has this thing called a cave. So it's a big room, and there's projectors on the ceiling and everything else, kind of like, I don't know, kind of like the holodeck, right? That kind of thing. But when you walk in, I think what was interesting to me was he's not just kind of like looking around the crime scene, but he can actually interact with the results of my analysis. So you can see the the trajectories of the bloodstains coming off the wall, and he can kind of look around and he sees it in the context of the crime scene. So I think there needs to be more work done there, and I think that's kind of interesting because now, for example, you can take jurors there, right? So it's it's an investigative tool, but it's also something that a jury or a judge or a jury or whatever could sit with some goggles on and then have a look around. And there's just some things that, and just for example, elevation. I have a case where it's like a guy falls off this cliff and he goes down, and it's like 100-foot drop or whatever. And when you look at the photos, you probably, if you've taken a photo of a mountain landscape or whatever, and there's a big mountain in the background, you don't get the sense of depth, right? Like you don't get the sense of height sometimes. It just looks like, I don't know, maybe it's deep, whatever. But imagine putting yourself at the edge of the cliff. You're standing there now in virtual reality and then looking down at the ground. Then it's like, whoa, this is, I don't feel comfortable with being here in VR. You want to take a step back. And so giving somebody a sense of those types of elevation differences and sort of what a witness might have seen, different perspectives, can be useful. It can be really useful, but it can be dangerous too. It can be harmful too.
Yeah, I mean, the first thing that kind of popped into my mind there is I can almost see an opportunity for that to create an increased traumatic experience for people. I mean, when you think about the average citizen, right, that sits in on a jury, just looking at still photos of a crime scene is going to be a bit traumatic for them. But to put them in a 3D environment where they can actually see, in kind of real time, if you will, what that looks like, I think that could potentially be pretty traumatic for some people.
Yeah, it could be, especially if you're doing some kind of a reenactment, let's say, like you're trying to reenact something that happened or whatever. Now, one of the things you can do is you can clean up the data, right? Like, so you can remove a body or something like that, and then just kind of say, okay, this is, the body's been removed, and you're just kind of looking at a cleaned up crime scene. But the other danger is, today, for example, there are companies that do a lot of animation stuff. So they have people running around and doing shootings. And if you recreate something in virtual reality, there's always the danger that you could, let's say it's a witness, it's an eyewitness. There's always the danger of inserting a false memory. So, it's not done exactly right. And then it's like, oh yeah, I think he punched that guy. I think that's what happened, but it never happened. Right. So, there are some dangers that, people can get a false sense of reality, by doing something like that. And, we're not there yet, fortunately, but, there are ways to sort of back off from there and just try to keep it, just the facts kind of thing and help it out. So, but there's some interesting things there. 3D printing has been pretty helpful, pretty useful. In fact, so here's an example. This is a 3D printed finger. So it's somebody's finger that's been scanned. So if you're a latent print examiner, and it's like today you just kind of show a piece of paper, and it's like got a picture of a print recovered at a crime scene, and then maybe you've got the suspect's a rolled print or whatever. But what if you could print it out, the actual suspect's finger, and like you can even, I know it's hard to see maybe there, but there's actually ridges here, and you can hear them. If I scratch my fingers on them, but you can color code this and then hand this to a juror, and now they have a blown up copy of the surface of somebody's finger.
Wow!
So that can be helpful in learning, and the same goes for other things. So this one is a vertebrae. This is from a homicide. So this is from a homicide overseas where there's a woman who got stabbed and she's got a cut mark on one of her vertebrae. And so we scanned the vertebrae and we actually have, so I think it's kind of cool. Well, to your point, if I took the actual bone and brought it into court and gave it to somebody, they'd be freaking out, right? So, but here it's kind of neat that I have a copy of this woman's bone in plastic that I can hold in my hand.
Right.
It's rather benign. It's not as traumatic or whatever. So, yeah, there's a lot of cool things. Yeah, there's a lot of cool things we can do with 3D data.
Yeah. And so for those that are listening to the show and not seeing it, if you want to see the items that Eugene was showing us, you can check out the video version either on the website at psi.chat, or you can just go to YouTube and pull up Public Safety Innovators Podcast, and you can watch the video of this interview there, and you'll be able to see those items. Eugene, there was one other question I was going to ask you, and I was going to frame this as part of the future concept idea, but admittedly, I don't know if maybe this is already happening now. So you're going to have to tell me. But one of the uses that I, have pop into my brain that I think would be really useful for 3D technology like this is doing autopsies, medical examiners. Is that being done currently, or is that kind of one of those things that maybe there's a paradigm shift that needs to happen there in order to get that to start becoming more regular?
Yeah, it's not anything new anymore. It's something that's been done for quite some time, especially in Switzerland, the University of Bern. So Dr. Michael Talley and his team, there's a bunch of people that have been doing, for example, virtual autopsies or vertopsies. And there's even another gentleman who I met most recently, and they're doing something called vertoscan, I think is what it's called. So they're combining all this 3D data, both CT, MRI, which really it's a volume it's getting on the inside. And so imagine you've got a victim and there's, bullet fragments and there's other stuff inside the body, maybe it's shotgun pellets or whatever inside. Or even consider a car accident where a pedestrian has broken some internal bones or something like that. Well, you can scan it and see the inside, and then you also scan the exterior. So you do surface scanning using photogrammetry or the structured light scanners that I talked about before, and you can combine the two. And so there is a case there where they rebuild the victim and they articulate the victim. So now you have a moving model of the victim, internal and external, with injuries based on the autopsy, what they did at the autopsy in this vertopsy. And then there's one paper that was published a while back, and they show, for example, they take this victim and they basically put him back on the roadway, and sort of in the configuration when they were hit by a vehicle. And you can see how all the injuries line up with the vehicle, the bumper, and all that sort of thing. So yeah, it's definitely being done, but it's not widely adopted just yet. And I think a lot of it has to do with the fact that the Swiss have a ton of money. So they've got like robots and all kinds of high-end equipment that would be prohibitive in other places of the world. So it has to be a much simpler and lower cost system. Yeah.
Sure. Well, Eugene, I'm really curious about how you actually got started in this field. So can you share with us just a little bit more about you personally, your background, and how you got into this in the first place?
Yeah, so my background is in aerospace engineering. So I studied engineering at school, and I got out and I was working in the industry for a while, and had a great start to my career. Great boss, had a great job in a materials and process engineering lab at what used to be McDonnell Douglas, and then it became Boeing. They bought McDonnell Douglas at the time. So, in engineering, modeling and designing using computer-aided design or drafting software is always something that, I was taught, right in school. So 3D modeling was nothing new. But I think the first thing that I can remember that I thought was super cool was I was at a company in Seattle, and they make these big machines that wrap around aircraft and stuff like that. And in order to get the aircraft or aligned properly and everything, they had this laser tracker. And so the guy had this little probe, right? And he moves this probe, and there's a laser that's following it. And you kind of move around, and the machine just kind of keeps looking at where this little probe is. And I thought, man, that's super cool. So that's the first time I saw a laser 3D device. And over time, I started getting these ideas about modeling, and I was modeling machines and stuff like that for concepts. Like, how do you get a difficult machine concept across? Because the company I was working for was creating these machines or making these machines. They're rather complicated, but if I just explained it to you, it wouldn't make any sense. I did a 3D model of one, and I emailed a 10-second video of how I wanted this thing to work. And 5 minutes later, I got emails back. Hey, this is amazing. Like, how'd you do this? Like this, I get it. It made a lot of sense. So from there, I started looking at where you can apply all this 3D stuff in other areas. And I looked at robotics. I looked at all these other areas. And when I looked at forensics, I was like, man, this makes a lot of sense, because there's a lot of complex things that happen in cases and shootings or whatever that can be applied. So basically, I started back, officially started in 2005. And I, what I thought I was going to be doing and what I'm doing today are different, but for the better, for sure. I'm getting into some
welcome
cool
to
stuff.
my life too.
Yeah, exactly. So along the way, I did a lot of, the introduction to the University of Toronto and their forensic science program. I think that was pretty good for me. Back in 2010, I got somebody said, "Hey, come out and show us what you're talking about, because we don't know what this 3D stuff is. Like, whatever, just come out." So I went out, and they were doing like clandestine grave exercises where they were excavating bodies, kind of thing. So I just took a few pictures, and then I created this 3D model, and they were like, "Holy mackerel! Like, you can do this?" I'm like, "Yeah, this is how it works." So a relationship started, and so I've been teaching there since 2013, and we do a lot of research now in so many areas: anthropology, the shooting stuff, the bloodstain stuff. So yeah, that's kind of how it's shifted, and kind of what how things progressed.
Awesome. Well, do you have any closing thoughts for us, or anything you wanted to cover here today that we haven't done so already?
You covered a lot of stuff already. Maybe nothing in particular, but hey, if anybody's interested in getting started or whatever, they can contact you, and maybe you can put them on to me. I'm more than, I help people a lot sometimes when they're just getting into this particular area, if they think that it's new. They can reach out to me, and I'm very open, and I try to help out wherever I can. So that's all I would say at this point.
Yeah, no, we'll definitely encourage folks to reach out to you directly. I don't need to be your gatekeeper. So you're really active on social media and on your website, and you've got a YouTube channel that you're really active on as well. So why don't you go ahead and let everybody know that's listening, where can they find you? How do they connect with you? Go ahead.
Yeah, sure. Okay. So the website is ai2-3d.com. And if you go there, I'll have links to all the other stuff on YouTube. I have another, just like you, I've got a little thing that I do called Forensics Talks, and that one is where I interview forensic professionals from all over the world, all different stuff, like way out of my wheelhouse, stuff that's not my specialty, kind of thing, which makes it really interesting. Also on YouTube, if you just do a search for 3D forensics, then you'll get to my channel, and I have stuff on laser scanning and photogrammetry and all that sort of thing. And but if you just want to reach out to me, just go to the website ai2-3d.com, go to the contact form. That email comes to me directly. So, I'll be able to see it, and I'll be able to get it. And like I said, I'm more than happy to respond to anybody who needs a hand.
Awesome. Well, it's been good having you on the show, Eugene. And as always, everybody, if you want to check out any of the resources that Eugene talked about today on the show, or go to his website or any of the other places that you can find him, we'll put all the links for all of that on the episode page in the show notes. And you can find that just by going to psi.chat/ and then the number of the episode. So go ahead and go there to find the links. Eugene, it's been awesome chatting with you, man. I could probably talk to you for another hour. I just find this stuff fascinating. So thanks for educating me a little bit.
Oh, thank you very much for having me. I appreciate it.
Hey, thanks for sticking around till the end of the show. If you enjoyed this episode, please consider leaving a review at psi.chat/review. I would love to hear your feedback, and it will also help other public safety innovators like yourself find the show. Be sure to check out the show notes for this episode. Just go to psi.chat, click on episodes, and search this episode number, and you'll find all the links, descriptions, and resources we talked about. And if you haven't already, make sure you subscribe, and you'll be notified when the next episode is live. Thanks again for tuning in, and I'll catch you guys on the next episode.